All right, today we have 5.8 solutions to quadratic equations. Our objectives today are to identify the best method for solving a quadratic equation. Okay, you've learned all these different strategies. Now we're going to have some time to pick the one to use. We're going to evaluate the discriminant to classify the nature and number of solutions to a quadratic equation. We're going to write a quadratic equation when given the rational, irrational, or complex roots. Yikes. And solve some real-world applications involving quadratic equations. Okay, so notice this box, right? This table that we've got is our techniques for solving the quadratic equations ax squared plus bx plus c equals 0. The first thing we used was factoring. We learned a couple different ways to do factoring. Okay, this is when you should use it when the polynomial factors easily or if c equals 0. And they have an example here, like x squared plus x minus 42 equals 0. And you factor out the common factors. Okay, then we have taking roots. You should use it when b equals 0 or the polynomial is that perfect square. Okay, is when we should use it. So we're like, oh, this is a perfect square because we see this square here. All right, the quadratic formula. You should use it when the previous methods are difficult. If anything is difficult, the quadratic formula is always going to be there. Completing the square. I think this one's funny. Use it when you're directed to do so. Just when I tell you, right? Just when it tells you to do it, should you use it. It's not one that, again, like I said, that people really like the most generally, but when you're directed to do it. So we have a whole gamut of things there, though, to use. And you have the examples on that. When the quadratic formula is used, the value of the radicand says indicates the number and type of solutions. Okay, so that's kind of cool. We haven't really talked about that. So when the quadratic formula is used, the value of the radicand indicates the number and type of solutions. Okay, so this value, d, okay, equals b squared minus 4ac. So we use it in the quadratic formula all the time, right? When we have that b squared minus the square root of 4ac, okay, is called the discriminant. What's under that radical right there, that is your discriminant. That is your discriminant. We're going to talk about it some more. All right. So let's look at example 1. And, excuse me, sorry about that. And let's solve some things that we've got here. All right, so we've got 3x squared equals 54. All right, well, if you'll notice, if we compare this to our ax squared plus bx plus c idea, all right, we don't have a b. There is no b value. So a simple way to solve this would be to take the root of everything, right? Solve by taking roots. So we're going to do the square, well, psych, not the square root. I needed to rewrite it. So let's get started. So we've got 3x squared equals 54. We can't take the square root until we have x by itself. So we're going to divide by 3. And we get x squared equals 18. Now we can solve by taking roots. Okay, so we take the square root and we get x equals plus or minus, and we need to do some math here. Okay, so I'm going to do 18 divided by 2 is 9 divided by 3 is 3. So this is equal to 3 times the square root of 2. So x is equal to plus or minus 3 times the square root of 2. All right, again, we're doing solving by taking roots here. Okay, let's look at B. We have 4x squared minus 12x equals 0. All right, well, since our C equals 0, all right, that's a pretty nice one, we can factor. We can just factor this one. All right, so what do 4x squared and 12x have in common? Well, they have a 4x. We can start there. 4x squared divided by 4x leaves us with x. Negative 12x divided by 4x is going to leave us with a negative 3x. Remember that equals 0. Now we split it. We change colors here. So then we have 4x equals 0 and x minus 3x equals 0. Oh, not 3x. Goodness gracious. I need like a teeny tiny eraser. All right, so it's x minus 3 equals 0. All right, then we solve for x. So we divide by 4 on this side. X equals 0 divided by 4 is 0. We add 3 over here. So x equals 3. Those are the answers, x equals 0 or x equals 3. C, our last one, we've got 3x squared minus 4x plus 5 equals 0. So our we have a b value. Our c does not equal 0. It's a little harder. We could try factoring, right? We've got a 3 and a 5. So that's 15. We're trying to get negative 4. If we're looking for those factors, 1 and 15 are factors. 3 and 5 are factors. None of those are going to get me a negative 4. This is when I have to go or want to use the quadratic. So I'm just going to put the quad equation there. All right. So the quadratic formula, however you want to do it. Okay, so we're going to have x equals. So we've got a is 3, b is negative 4, and c is positive 5. So x equals negative b, so negative 4, plus or minus the square root of b squared, so negative 4 squared, minus, not plus, okay, minus 4 times a, which is 3, times c, which is 5, all over 2a, and a is 3. All right, so this equals a negative 4 is a positive 4, plus or minus the square root. Negative 4 squared is 16, minus 4 times 3 is 12. 12 times 5 is 60. All over 2 times 3 is 6. All right, I'm going to save some space here. So this is going to equal 4 plus or minus the square root. 16 minus 60 is going to give me negative 44. All over 6. Okay. Well, we've got that negative, so we know that's an I. So x is equal to plus or minus, or 4 plus or minus. And let's do the division of primes with 44. So let's see, 44, if I divide by 11, I get 4, divide by 2, and I get 2. So because I have two 2's, I can bring them out. So I'm going to bring a 2 out from underneath there, my radicand. I'm going to bring my negative out as an I, and I'm going to leave my square root of 11 under there. Divide by 6. Okay, now I can simplify still because I have a 4, a 2, and a 6. Okay, and they all have a 2 in common. So 4 divided by 2 is 2. 2 divided by 2 is 1. 6 divided by 2 is 3. So this would be 2 plus or minus I times the square root of 11 divided by 3. It didn't say we had to write it as a decimal or anything, so we can just leave it like that. But again, we're trying to pick out which ones to use a little bit. All right, let's clear these. And let's look at example 2. It says solve 4x squared plus 49 equals 28x as directed. Okay, because again, you can kind of solve, some of them you can solve any way you want. It's just practicing with them. All right, but if we look at A, we have by factoring, B is completing the square, C is quadratic equation. First up, there's a problem here, right? It's not in its necessary form. So we need to subtract 28x so that we have 4x squared minus 28x plus 49 equals 0. Okay. So 4, 28, 49 don't have anything in common. I was like, oh, there's a 4. 4 can't go into 49. So we need to do 49 times 4, which is, I don't know why I wrote it like that. You're not in 3rd grade. Okay, so let's look at 49 times 4. That's going to equal, what, 196? Let me check it on my calculator. Yep, 196. We need factors of 196 that equal 28. All right, and 14 times 14 equals 196. But we need a negative 28, so we're going to make it negative 14 times negative 14. Because negative 14 plus negative 14 is going to equal negative 28, which is exactly what we need. Okay, so I'm going to have 4x squared minus 14x minus 14x plus 49. Because remember, we split this into 2 parts. And I'm going to have to erase my work here so I can do the actual work. All right, so that equals 0. Okay, I'm going to make my 2 groups here. 4x squared minus 14x, they both have a 2x in common. So 4x squared divided by 2x is going to leave me with 2x minus 7. And negative 14x and 49, I can take out a negative 14. No, not 14. 14 won't go into 49. So negative 7. And negative 14 divided by negative 7 is going to leave me with a positive 2x. 49 divided by negative 7 is going to leave me with a negative 7. So I have 2x minus 7 times 2x minus 7 equals 0. Nice that these are together, so I only have to solve one of them. So 2x minus 7 equals 0. So I add 7 to both sides. 2x equals positive 7. Divide by 2. And x equals 7 halves. Notice we only have one solution because these are the same factors. These binomials are both the same. 2x minus 7 and 2x minus 7. Okay, if we do completing the square here, let me rewrite our equation correctly. So it's 4x squared minus 28x plus 49 equals 0. Okay, in completing the square, we need the 49 on this side. So we would have 4x squared minus 28x equals negative 49, if you recall. All right, then we're going to add, so we have 4x squared minus 28x, and then we add the b value, negative 28. Let's see, 28 over 2. So the b value, half of the b value squared, to both sides. So it equals negative 49. Change my color. Plus 28 halves squared. Okay, well 28 halves is really, 28 divided by 2 is 14, is it not? Oh, you know what I forgot to do? Dang it, these numbers are big. I knew it. I also have to divide by 4 first. I get ahead of myself sometimes. So divide by 4. So then we would have x squared minus 28 divided by 4 is 7. X equals negative 49 fourths, which is just that ugly number that nobody wants to have to deal with. Okay, so now we're going to have x squared minus 7x. We're going to add the b, 7 divided by 2 squared. And this is going to equal your negative 49 fourths plus 7 over 2 squared. Okay, so then when we do that, we take the square root. Remember, we can kind of pull that out. So this is going to be x, it's a minus, so this is going to be minus 7 over 2 squared equals, all right, let's see, 7 squared is 49, 2 squared is 4. So, oh, check that out. Negative 49 fourths plus 49 fourths is actually 0. That makes it nicer. Doesn't happen very often. Okay, so now we need to set one of these equal to 0. So x minus 7 over 2 equals 0. So we can just add 7 over 2. And we get x equals 7 halves. Just like we got on A. Or we could do C, solving it with a quadratic. All right, so in that one, we've got it set up right. 4x squared minus 28x plus 49 equals 0. So we're going to have x equals negative b, and our b is negative 28. 28, yikes, plus or minus the square root of b, negative 28, squared, minus 4a, which is 4, c, which is 49, all over 2a, which is 4. Okay, so then we've got this equals a positive 28 plus or minus the square root. Negative 28 squared is 784 minus 4 times 4 is 16. 16 times 49 is 784. And that's all over 8. All right, let's erase here. Always make that line a little too long so I can have some space. All right, so that's going to equal 28 plus or minus 0, right? Divided by 8. 28 over 8, they both can be divided by 4. 8 divided by 4 is 2. 28 divided by 4 is 7. So x equals 7 over 2. Okay, so again, you can solve them any way you want most of the time. Like some of the strategies work, but it's up. So sometimes it's up to you, completely up to you. Okay, so now let's look at this idea of determining the number of and type of solutions, like this determinant earlier. I'm sorry, discriminant. Did I say determinant earlier? It's the discriminant. I might have spelled it wrong even. I probably typed it wrong at the front. I'm sorry. All right, so determining the number and type of solution. So D is equal to that b squared minus 4ac, the part that's under the quadratic, under the radicand, pardon me, in the quadratic. So if D is greater than 0 and it's a perfect square, then we're going to have two rational solutions. So here's an example. See right here? All right. We've got the radicand. That's the 4ac and all that. Okay. So it equals -1. Or we get 3 over 2 and it equals -1. Or 3 over 2 and -1. But we're looking at the part that's under the radical. Okay, so it's greater than 0 and it's a perfect square because it was 25. So we have two rational answers. And the answers are 3 over 2 and -1. Okay, if D is greater than 0 but not a perfect square, we get two irrational answers. So here we have 1.15 and -0.65, but notice it's because the number under the radical, 13, is not a perfect square. So we get irrational numbers. Okay, then in D is equal to 0, so the number under the radicand is 0, we get one rational answer, 1/4. And if D is less than 0, notice we have under the radical is a -9. So if this is less than 0, you might put a negative number. We're going to have a pair of complex conjugates. So here we have the 1/4 plus or minus 3/4 I. This may look like one answer, but remember it's 1/4 plus 3/4 I and 1/4 minus 3/4 I. It is a pair. We just write it together with the plus and minus. Okay, so the discriminant is related to discriminate, which means to distinguish or to differentiate. Okay, we're differentiating between these. So examples 3 says use the discriminant to determine the number and nature of the two solutions. Okay, that was given up here. So in this, the number and the nature. The number is 2, the nature is irrational. Okay, so this first part is the number in the solution, and this is the nature of the solution. Okay, so to do this, we're going to write the equation in standard form. 3x squared plus 5x plus 8 equals 0. Check. It's in standard form. Determine the values of a, b, and c. A is 3, b is 5, c is 8. Calculate the discriminant. Okay, so just think about it's the square root of b squared, right? It's what is under the square root. So if it's easier for you to think about, like saying the whole thing, because it's what's under the square root that matters. Remember, what's under the square root is b squared minus 4ac. So b squared is 5, so this is 5 squared minus 4 times a, which is 3, times c, which is 8. So this is equal to 25 minus 4 times 3 is 12, and 12 times 8 is 96. So 25 minus 96 is -71. All right, so D is equal to -71. Okay. First of all, not the square root, it's what's under the square root is our D. Okay, I just put the square root in there because it's kind of how we've seen it. You don't have to do that. All right, so if our discriminant is -71, that falls in this category, right? It's a negative, it's less than 0, it's a negative number. So we're going to have a pair of complex conjugates, or 2 complex conjugates is our answer here. So 2 complex conjugates. That's the number and nature of the solution for that problem. All right, so let's look at B. If we go back to step 1, standard form, it's not there, so we've got to subtract 4 from both sides. So we have 12x, never mind. We've got to put our x squared first, negative 9x, let's just do it here, negative 9x squared plus 12x minus 4 equals 0. We're still not good, because I can't have a negative to start with. All right, so I need to divide by negative 1. So that's going to give me 9x squared minus 12x plus 4 equals 0. Okay, now that I have that, determine my values of a, b, and c. So a is 9, b is negative 12, c is 4, and we're ready to calculate the discriminant. So we've got, again, looking for this b squared minus 4ac. So b squared is negative 12 squared minus 4 times a, which is 9, times c, which is 4. Again, you can put the square root there if you want. You don't have to. All right, 12 squared is 144 minus 4 times 4. I would actually do that. 4 times 4 is 16. 16 times 9 is 144. 144 minus 144 is 0. So D equals 0. When D is equal to 0, we have one rational solution. Okay, that one's going to have one rational solution. Okay. So again, you're not actually finding the square root if you use that, just the number under the square root, or the radicand. Okay, let me go back. Did that say determinant? No, it did say discriminant. It's been bugging me. All right, so recall that reversing the steps used to solve a quadratic equation by factoring can produce a quadratic equation that has stated values as its solutions. So we did this earlier, okay, but we're reversing the steps used to solve a quadratic equation can produce a quadratic equation that has stated values as its solution. So if an equation has only one solution, so if we have one solution, use the corresponding factor twice. So you're going to use it 2 times. If an equation has imaginary or irrational solutions, reverse the steps used to solve equations by taking roots. So reverse it by taking roots. Okay, so we're going to look at an example for both of those. So example 4, we're going to write a standard form quadratic equation with the given solutions. So A, x is equal to 2/3. That's an example of this first one. If an equation has only one solution, right, we just have one solution, use the corresponding factor twice. All right. Well, first of all, we've got to get this. We have x equals 2/3. Well, this is 2 divided by 3, so we're going to multiply by 3 on both sides. Then we get 3x equals 2. All right. Then we're going to subtract 2, and we get 3x minus 2 equals 0. All right. So this is our factor. Right? That binomial is our factor. And it says use the corresponding, that's why it says corresponding, factor twice. So I'm going to take 3x, actually let me change up colors here to show a different step. So I'm going to take this 3x minus 2 quantity, and I'm going to use it twice. And then I'm going to FOIL. Okay, so 3x times 3x is 9x squared. 3x times negative 2 is negative 6x. Negative 2 times 3x is negative 6x. Negative 2 times negative 2 is positive 4. We're going to combine our like terms, and we get 9x squared minus 12x plus 4 equals 0. We have just written a quadratic equation from the solution. Okay, in B is an example of when we have an imaginary solution. Okay, we're going to reverse the steps used to solve the equation by taking roots, which means at some point we're going to square it. But first of all, we have to um, in order to square it, we have to isolate the squared term. Okay, so we need to subtract 5 from both sides. So x minus 5 equals the plus or minus 2i times the square root of 7. All right, so we need to square each side. Okay, so again, I'm going to switch up my colors to show, well, I guess, no, I won't, because I'm not changing. I don't have my term yet. Okay, so I need to take this side, right, and square it, and take this side and square it. Okay, so x minus 5 squared. So I'm going to have x minus 5 times x minus 5. You might recall the shortcut for this because it's a square of differences. Okay, but if not, I'll FOIL it out so you know. So x times x is x squared. X times negative 5 is minus 5x. Negative 5 times x, minus 5x. Negative 5 times negative 5 is plus 25. Okay, and then we need to square this number, or this side over here. So we have 2i times the square root of 7 times 2i times the square root of 7. Okay. All right, well, we know that 2 times 2, and maybe, I don't know if that helps. Actually, that might be more confusing if I write it out, because it's not a binomial, it's just a monomial. So let's not. Okay, so 2 squared, well, when we square, we're going to get rid of this plus and minus. 2 squared is 4. Okay, so then we're going to have 4. I squared, and then the square root of 7 squared is 7. Okay, so we've got 4i squared times 7. Well, 4 times 7 is 28. I squared is equal to negative 1, so this is negative 28. We're going to combine our like terms here. So we have x squared minus 10x plus 25 equals negative 28. We're not quite in quadratic form. We can't have this negative 28. So we're going to add 28 to both sides. And we have x squared minus 10x plus 53, right? 53 equals 0. Yes. Okay, so that's how we do it if we have an imaginary or a rational solution. Because we had to take the square root, so at some point we have to square both sides to get to the factor. All right, that is it today. I will see you later.